Hi everyone, welcome to another video, and in this video we are going to talk about another routing protocol which is very important for your CCNA exam. This is the only protocol which is you need to know in detail, and this is OSPF, which is Open Shortest Path First. For your CCNA level, we are only going to discuss single area OSPF. So there are single area OSPF and multi-area OSPF. Multi-area OSPF is a bit advanced topic which we are not going to discuss today because it is not included as a part of your CCNA objectives. So we are just going to discuss the normal OSPF. So yeah, let us begin with the OSPF. So there are quite a few points which we need to note about OSPF. So the first point is I've written in a text file, which is it is a link state protocol. So it is based on the bandwidth of a link. If we talk about RIP, so yeah, so we have discussed RIP and static and floating routes earlier on this channel, this series. So you can go back and watch those videos, link in the I button. In RIP is also a dynamic protocol. So there are static protocols and there are dynamic protocol. Dynamic means the routing will happen automatically, as we discussed in our RIP video. In a static, on every router we need to manually go and define that route, right? So OSPF is a dynamic protocol, means the route will propagate automatically. We don't need to manually assign route to we don't need to go to every router and assign route table and create a route table manually. So that is about OSPF. Now one more thing is there, interior gateway protocols and exterior gateway protocols. So IGP and EGP. Interior gateway protocols means which you can implement inside a network, right? An external gateway protocol means it will connect two different networks. So in external gateway protocol, we have protocols like BGP, which suppose I have a different ISP, suppose AT&T, and you have a different ISP, suppose Verizon. So to connect both of these networks, these ISP networks together, we use a BGP route in between. But inside these ISPs, we tend to use IGP, which is Interior Gateway Protocol. And it is a protocol like OSPF. So OSPF is also considered as an IGP protocol. So that is the second thing we need to discuss for OSPF. Now the third thing which we also saw in the notes were it uses bandwidth to calculate the distance between each router. So what happens in case of RIP, we count the hops, means routers. So if suppose this is a PC A, this is a PC B, and we are using RIP, so we will count the number of hops, number of routers in between. So if we go from 2 to 1 to 4, we have 2 routers, right? So, and then we have 2 to 3 to 4, we have only one router in between. So basically 2 links. Here also there are 2 links. Here also there are 2 links. Now if we go here 2 to 5 to 6 to 4, we have 1, 2, 3. 3 links and 2 routers. So basically RIP will count, it will not use 2 to 5 to 6 to 4. It will either use 2 to 1 to 4 or it will use 2 to 3 to 4. So it just counts the number of hops, number of routers. Hops equal to router. It will count the number of hops and it will calculate in that way. So in case of a OSPF routing protocol, we calculate the bandwidth. Now, firstly, we need to set a reference bandwidth on the router. So by default on Cisco routers, the reference bandwidth is 100 Mbps. So this reference bandwidth is used to calculate the cost. So if we have a 100 Mbps reference bandwidth, then if this is a link of 100 Mbps, we will have a cost of 100 upon 100. Now if we have a link of 10 Mbps here, the cost will go up to 10. So this will be cost of 1, this will be cost of 10 if we are using 100 Mbps as a reference bandwidth. I have collected these results from this study ccna.com/OSPF cost metrics. So you can go to this website and you can also search for that. But for now, we need to understand that suppose this is a 100 Mbps link, this is a 10 Mbps link. Now here we have a 100 Mbps link and this one is also 100 Mbps link. Now this one is a 200 Mbps link suppose, and this one is a 10 Mbps link, and this one is a 1.544 Mbps link, which is the DS1 line. So now OSPF will calculate based on the bandwidth. So this will be the cost 1 plus this will be the cost from 2 to 1, cost will be 1, from 1 to 4 cost will be 10, because 100 Mbps is the reference and we divide it by 10, so it will be 10. Now for 2 to 3 to 4 it will be 1 plus 1. So first will be 2 to 1 to 4. This route has a cost of 11. 2 to 3 to 4, this route will have a cost of 2. And then we have 200 Mbps, then 10, and then 1.544. So if we calculate 200 Mbps, so we'll divide 100 by 200, it will be 0.5. So we have 2 to 5 to 6 to 4. So this route will have a cost of 0.5, then this will be 10, and this will be 64. So 64 plus 10 will be, you can see the reference bandwidth on this table here. So 64 plus 10 will be 74 and 74.5. Lowest cost will be chosen. So this route will be chosen for OSPF, which will be A to 2 to 3 to 4 to B. So it will depend on the bandwidth of the link. So this is how OSPF works in general. And this is the main difference between RIP and OSPF. RIP and OSPF main difference is, first one is, RIP is limited to 15 routers, 15 hops, right? As we discussed on the RIP video. OSPF is unlimited. You can have unlimited number of routers running OSPF. So this is like unlimited in, if you say infinite, right? The second difference between both of these, this counts the number of routers and this counts the bandwidth of the links which are connecting these routers. So this is based on the bandwidth, this is based on the hop count or router counts. So these are the basic difference between RIP and OSPF, and we generally tend to use OSPF because it is a more efficient protocol and we can run this in unlimited number of routers. And using bandwidth is a more it's a better way to decide the route, because what can happen in case of suppose RIP, suppose there are one router, two router, and both of these have, suppose there are one more, so two routers are there, 1, 2 and 3. So if traffic wants to go from 1 to 3 and this link has a bandwidth of 10 Mbps, right? And both of these will have bandwidth of 100 Mbps. Then in case of RIP, it will choose this 10 because it will count the number of routers. Like there are no routers in between both of these links. So what will happen that this will go to waste, this 100 Mbps links, right? This will not be chosen. So more efficient way is the OSPF. Using OSPF is like kind of a more efficient, but RIP we use in a very small amount of because basically if you see the RIP, it has less number of calculations while calculating the routes. So if we have suppose less than 10 routes in a routers in a network, then we tend to use RIP in that case, because routers have a limited memory and they also have RAM and all, CPU and all those things. And RIP is generally more like it's a low resource consuming protocol. OSPF is a more resource consuming protocol, but there are benefits to the OSPF. We can use it in unlimited. So these are the basic difference between RIP, OSPF, and what is OSPF we discussed in this video. And now we have to also note one thing: the administrative distance of OSPF is 110. So you can remember that because this comes handy while doing some basic calculation based or diagram based questions. So this is the basic thing about these protocols, that whenever a router is added or disconnected, so it should be thrown to every other route in the network. So RIP, we discussed that whenever a route gets changed, so it will slowly get propagated to the entire network. Now we'll discuss the same thing in the terms of OSPF, which is a bit complicated process. So yeah, we'll see that. Yeah, so we have 2 or 3 things in OSPF which we can use to calculate certain things. First thing is the router ID, second thing is the priority, third thing is the DR, and fourth thing is a BDR. Suppose there is no a normal protocol, this is normal protocol, and this router gets an update. Suppose a new route has been added to this. So what this router does, that it propagates through the entire network to every other router in the network, right? Then whenever 2 will send an update to 1, then 1 will resend that to every other router because 1 have received that. Then it will go to 4. 4 will also send to the every other router. So there might be congestion in the network because router is only added to the second router, but it propagated to all the other routers 1, 3 and 5. Then 1, 3 and 5 separately also propagate through the network. So this might add a congestion in the network, right? There might be a huge traffic of these update packets. So OSPF implements a mechanism. So we elect a BDR and a DR. DR is a designated router and BDR is the backup designated router. So it gets elected in an OSPF network. So it is based on the router ID and also the priority. So priority we can set manually, and the router ID will be chosen by the highest number of, suppose this is the router number 1, and this link will have some IP, right? And this link this link will have some IP and this link will have some IP. So whatever the highest number of highest IP, so suppose this is a 10.1.1.1, this is the 172.16.1.1, right? So this 172 is the highest, so it will be chosen as router ID for this router. Every other router will also have the same process to choose the router ID. So whatever the highest router ID is there, if you did not assign manually, so you can assign a BDR and DR manually as well. But in if it is happening automatically, so it will select the highest router ID, right? So for router number 1, the ID is 172.16.1.1. Suppose 4 has an ID of 8.8.2.5. So something like that. So the highest will be selected as a DR, and the second highest will be selected as BDR, which is backup designated router. So now what it changes in the process, suppose 2 has an update again, 2 will now send update to all the other routers. Suppose this router 6 has selected as DR, the 5 we selected as BDR, right? So what happens, suppose 2 gets an update, so that update will propagate through the entire network. Now the DR will receive it. All the other routers will ignore that message. Only DR will acknowledge that message, and now DR will send back to each of the router in the network that okay, this is the new update. So basically DR is like a way to remove that congestion, and BDR is just the backup. If DR fails or it gets lost, so the BDR becomes the new DR. I will again explain you because I think I went too fast on this. So what happens that we select a BDR and DR, we elect them based on the router ID. So whatever router has the highest number of router ID, that router gets selected as a DR, and the second highest will be BDR. Now when any of the route on the network gets an update, or not a network, you can say area. So OSPF, suppose this is a single area OSPF. So this is a area 0. OSPF area 0. So in this area, suppose this is a DR and this is a BDR. Every other router will receive the update that 2 has connected with a new route. Only DR will acknowledge it. All the other routers will ignore it, and DR will again send back to each of the router that okay, this is now the official update. Now you can update your routing tables based on the message from the DR. So this is the process of OSPF. I have linked one video of Cert Bros, very good video, like based on the graphics and all. So go through that video that explains the entire process, how it translates over the network, how the packets translate over the network, how the BDR and DR got elected. So if you do not understand what I am saying here, go to that video, you will understand everything. I have linked down in the description, so please check them out. It's a great channel, subscribe them also. So yeah, this is about DR, BDR, OSPF, RIP and the differences. So in this video, it's all about this. In the next video, we are so I'm also going to bring a OSPF part 2, because this is a really important protocol. And that video, we are going to go to packet tracer and we are going to implement some labs on OSPF. And we'll see how this BDR DR gets elected, or how can I change the priority of the router. How can I manually select DR and BDR on a network, and how the router ID is calculated. All those things we're going to see in the lab section, which will be coming soon, hopefully. So yeah, that's all about it in this video. So thanks for watching. Thank you for your time and have a good day. All the best for your CCNA.